Welcome Algebra 2. This video is on graphing logarithmic functions. The essential question is, how will you graph logarithmic functions? Let's begin. So what does this log function actually look like? Well, a log function is the inverse of the exponential function, So in red I have the exponential, and in blue I have the logarithmic function. One way it's the inverse is it's actually mirrored on this line right here, the line of y equals x. It actually reflects off that line. So here it is again. The reflection of the equations, if you're going from log to the exponential function, reflects on that purple line right there. So what is the domain and range of log functions? The domain, for this case, I have the graph of y equals log of x, and that's like log base 10. The domain is x is greater than 0. So it's all values for x that keep the log positive. Because one thing you got to remember, you can't take like a log of a -1. I can't do log of -1 like that. I can only do logs of positive numbers. So the domain is going to be any values for x that make inside that log function positive. I have to only evaluate positive numbers. So in this case, for log of x, it's all values for x greater than 0. And the range is going to be all real numbers, because you're going down forever and you're going up forever. Even though it's going to the right, it still keeps going up slightly. So your range is all real numbers. Remember, from exponentials, the domain was all real numbers. We also, for this function, if I have log of x plus 1 minus 3, the domain in this case is we're going to be x values are going to be all greater than -1, because -1 is the smallest value. If you plug in log of -1, -1 plus 1, that'd be log of 0. You can't do log of 0, but any values greater than -1 would make inside this log positive. The range, again, all real numbers, because it's always going down forever and it's going up forever. Now the asymptotes. The asymptotes for log functions happen when y equals 0. So it's whatever value, in this case it's y equals 0. It's whatever value for x that makes you're evaluating a log of 0. So I'm going to say evaluate log of 0. So whatever gets the inside of this log function 0, that's your asymptote. In this case, for log of x, the asymptote is going to be at not y equals 0, x equals 0. That's a typo. So it's going to be at x equals 0, and that's the purple line right there. Now, if we're looking at a different function for this one, what value would make inside that log 0? Well, it'd be x plus 1 equals 0, because we have x plus 1 inside. So it's going to happen where x equals -1. So my asymptote is going to happen right here, where x equals -1. And you can kind of see that from the shape. It's just going down forever, but never actually touching. Let's look at the x-intercepts. So another neat thing to look at is, where's the x-intercept? It happens when y equals 0. And sometimes that's hard to just plug in and figure out. So, because log functions are a little different. But what I like to do, I can't see log functions very well. I always try to convert to exponential form to help me out. So I'm going to take this function, log equals 10, log base 10 of x. I'm going to convert that to exponential, so 10 to the y value equals x. Now, when y equals 0, that's my x-intercept. So that's going to happen when 10 to the 0 power equals x, or when x equals 1, because anything to the 0 power is 1. So my intercept here, y is 0, and my x value is 1. And that happens at that part, and that's correct. Going back to that other equation we worked on, again, I want to convert this to exponential form. So the first thing, you got to isolate the log. You can't just convert to exponential form right now because I have that -3. So the first thing I'm going to do is add 3 to both sides. And those will cancel, so you get y plus 3 equals log of x plus 1. Now I can convert to exponential form. So converting to exponential form, that's log base 10, you get 10 to the y plus 3 power equals x plus 1. But I want to isolate the x, so I'm going to subtract 1 from both sides. And what you're going to get is x equals 10 to the y plus 3 power minus 1. There's a lot of juggling with that, but if you're at this point, I bet you can pull that off. So I've isolated that, and I want to figure out what x will equal when y equals 0. So x is going to equal, I'm going to use that equation up here, x is going to equal 10 to the 0 plus 3 power minus 1, or 10 cubed minus 1. which is going to be 1,000 minus 1, or 999. So way over here, this point actually is the x-intercept. That's actually at 999, 0. All right. Some properties of log functions and translations. It follows a lot of the same stuff we've done before. That coefficient a will stretch and compress it. Translations, so the plus k value outside will do a horizontal translation that goes up and down. If you have the inside of the log x, the minus h value, that's going to move it to the left and to the right. So all the transformations together, it's the same concepts that we've done before. H and k is horizontal and vertical translations, and a stretches and compresses. Some typical types of logarithmic functions, we've seen this log of x function, where you're going up like this. Negative log of x, if you do have a negative sign in front, you're going to start up really high and then go down. It's going to be a shape like that. It's reflecting on the x-axis. Log of negative x, you're reflecting it on the y-axis. So it's going to look like that. It's going to be all negative values for x. And negative log of negative x is flipping on the y and x-axis. It's going to look like this. Now, how do you graph a log function? Oops. So there's a few different ways to do this. I'm going to first, you really have to figure out what the asymptote is. And that's going to happen whenever the log evaluates to 0. So inside of here, where's that going to happen? It's going to happen when x equals 0. So that's when you're going to actually try to do a log of 0. So the asymptote is at x equals 0. Now I want to find some other points here. The first easy point to find is whenever you're logging the value of 1. Because log of 1 always equals 0. So I try to find whatever x value is going to give me a log of 1 in here. So if I'm making my xy chart, to make that a log of 1, if x equals 1, you would be doing log base 5 of 1, which is going to equal 0. So whenever my x value is 1, if I plugged in 1 for x, my y value would be 0. So that's one point I can plug in. And I'm going to plot that right here. Now I want to get a second point. So it's hard. You can't just like plug x as 2 and try to do log base 5 at 2. That might not be easy for you to do right away. But what I really have to do is I want to convert this to exponential form, because I can see exponents a lot better. So writing this equation in exponential form, the log's already isolated. I'm going to go 5 to the y power equals x. And I'm going to plug in values for y and try to figure out what the corresponding x is. You're kind of doing it backwards. So if I had y, I started with 0, let's try y of 1. If you have y of 1, you have 5 to the 1 power, and that's going to be 5. So x equals 5. If y is 2, you have 5 to the second power, and that's going to equal 25, so x equals 25. So now I got some points here. I'm going to plot 5, 1. So 5, 1 happens right here. I'm going to label that 5, 1, and label this 1, 0. And 25, 2, it's like way over here. So I'm going to label this 25, 2. So I see a curve happening this side. If I know I'm going way out in this direction for log, the point where you're evaluating log of 1 is kind of like the turning point here. And you're going to actually go down from that point and along the asymptote. And in the other direction, I'm going up this way. And that's a rough graph of a log function. That's what I'm looking for. So let's try some examples. Pause the video. Okay, first thing I want to find my asymptote. That's going to happen when x minus 3 equals 0, so it's going to happen when x equals 3. And that's going to be a line right here at x equals 3. Now, I want to find some extra points. So the first point I want to figure out what I'm doing log of 1, log base 5 of 1. That's going to happen when x equals 4. So when x equals 4, you're going to have negative, this is going to be negative log base 5 of 4 minus 3, which is 1. So that's going to be negative 0 or just 0. So that's going to be y equals 0. Now I want to find some extra points. So I'm going to convert this equation into log form or to exponential form. The first thing, I got to isolate this log value. So I'm actually going to multiply or divide both sides by negative 1. So what I get is I get a new function of negative y equals log base 5 of x minus 3. Now I can convert to exponential form. So 5 to the negative y power equals x minus 3. And to isolate the x, I'm going to add 3 to both sides. So you get my x equals 5 to the negative y power plus 3. So I'm going to plug in values. I'll write that equation. 5 to the negative y plus 3 equals x. So I'm plugging values for y to figure out x. I'll start with y is 1. So if I plug in y as 1, I get 5 to the negative 1 power plus 3, which is going to actually equal 3 1/5. All right, so 3 1/5. Let's see. I'm going to plot the point 4, 0, and 3 1/5, 1. That's going to be right here. Huh. Okay, I want to actually pick a y value in the negative direction too. So negative 1, you're going to get 5 to the minus negative 1, or positive 1 plus 3. That's going to be 8. So negative 1, 8. It's going to happen right there. And you can kind of see a pattern here. I'm going to try negative 2. So you get 5 to the positive 2 power plus 3. It's going to be 28. And that's going to be like way over here, let's say. And you can see a curve happening, so I am going to start graphing it. So you should roughly have a shape like this. And that's your answer. I'm really bad at that. Next one, pause the video. Okay, let's graph that again. Again, my asymptote is going to be at x equals positive 1, because that's x minus 1 in there. It's going to be x equals positive 1. Now I want to plot a few more points. I want to figure out when you're doing log of 1, so my xy table. That's going to happen when x is 2. When you plug in 2 for x, you're going to get log of 2 minus 1, or log of 1 minus 3. And that's going to equal negative 3, because 0 minus 3. So plot the point 2, negative 3. All right, I want to do another point. I want to convert this to exponential form. So I'm going to add 3 to both sides. I'm going to get y plus 3 equals log x minus 1. And convert that to exponential form. That's log base 10. So I get 10 to the y plus 3 power equals x minus 1. And I'm going to add 1 to both sides. So I get x equals 10 to the y plus 3 plus 1. Now I got to plug in values for y. Well, I'm going to do y values that are going to make this exponent smaller. Because if you just plug in around the negative 3. So let's do a value. Let's try the value of negative 2. Y of negative 2, you're going to get 10 to the negative 2 plus 3, so 1 power plus 1. So your x is going to be 11. And let's try another value. We can go the other direction. We can go x of negative 4. So I get, well, let's not do that. I have enough points right here. So y and x is negative 2, x is 10. It's going to be about right out here. I think with those 2 points, I can see that in this direction, I'm going to be curving like that. And then going negative direction, I'm going to do the asymptote. So that's my rough graph of this. This is all you need to do. I'll label that point 2, negative 3. Last one, pause the video. Okay, log function. So my asymptote is going to be at negative 3. So I'm going to graph that. And then I want to figure out what value for x is going to make that the log, or the natural log. When you say ln, that's like log base e of x plus 3 minus 1. So the value that's going to make that 1 is going to be negative 2. And so when x is negative 2, you're going to have 0 minus 1, or negative 1. So plot that point, 2, negative 1. And I want to get a second point in there. I want to convert this to exponential form. So I'm going to add 1 to both sides. I get y plus 1 equals log base e, x plus 3. Converting that to exponential form, I'm going to get e to the y plus 1 power equals x plus 3. And then subtract 3 on both sides. You're going to get e to the y plus 1 power minus 3 equals x. All right, I know it's a little bit more difficult when you have an e in there. So e is about 2.71. Let's plug a y value in. I want to make this just e to the 1 power, so I'm going to plug a y value in of 0. If you plug in a y value of 0, you'll have e to the 1 power minus 3. So that's basically 2.71 minus 3. And that is going to equal roughly negative 0.29. So negative 0.29. All right. If I know that point, I can get a rough estimate of where to graph that. So that's going to be about y0, and negative 0.29 is going to be about right here. I got 2 points. I know that in the negative direction, I'm going to be along the asymptote. So I can sketch this curve, and I can just do something like that. And that's all I'm looking for. That's it.